Hi, I'm Miss Hearn. Let's get started. Here's an example of a logarithmic equation that we can solve by writing it in exponential form. Now you can't rewrite it in exponential form until the log is by itself. So the very first step is to isolate the log term, actually the log factor, because what's happening here is the 33 is being multiplied by log base 5. And we want to get the log by itself. How do we do that? That's right, we're going to divide both sides by 33. So we now have log base 5 of 4p plus 17 is equal to what? 2. Okay, now, this is what's called a logarithmic equation. Why do we know it's a logarithmic equation? Not just because there's a log in it, but also because the variable you're looking for is inside the argument of the logarithm. It's kind of like it's trapped in that log and we have to free it. And the way we're going to free it is just to go to exponential form, okay? So at your desk, write down what you think the exponential form of this logarithmic equation would be. If you're not sure, just guess. And then I'm going to write it and you'll see how close you were. This way you know if your instincts are matching up with what you're supposed to do, or if they're not, in what way you need to adjust that. So the way that I do this is I think, okay, this left side means 5 to what power gives me 4p plus 17. 5 to what power gives me 4p plus 17, but it's giving me the answer. The answer is 2, right? So it's 5 to the second power gives me 4p plus 17. This is the exponential form of the logarithmic equation. Now, why is this helpful? Because we have freed that variable p from the grasp of the logarithm, right? It's out now. We can now isolate p like we normally do. Of course, I'm not going to leave 5 squared. I'm going to write what? 25 equals 4p plus 17. And now we just have what kind of equation? Linear, which is our favorite, because all you have to do is rearrange it, right? So I'm going to subtract 17. And we're going to have 8 equals 4p. Dividing by 4, we're going to have p equals 2. Now there is one thing you always have to keep in mind. Remember how when we solved radical equations, we had to check our answer because when you square both sides, it can create an extraneous solution? Well, with logarithms, there's that little issue of you can only plug a positive number into a log. So you always have to check. You don't have to check completely, but what you have to check is that the argument of any logarithm is positive, not 0 and not negative. So what I mean by that, by argument, the argument of this logarithm was 4p plus 17. So if I plug 2 into 4p plus 17, do I get a positive number? Yeah, I get 25, right? Which is definitely positive. So we're okay. You don't actually have to check the whole equation. Sometimes the equations are very complicated. You don't want to have to plug everything in, but at least check to make sure that the arguments are positive if you plug in the number you got for the answer. I hope you found this video useful. If you did, please remember to like it.